the fourth lecture of the course operating system. So in today's lecture, we'll be discussing the different types of processors that are available. Okay. So first we'll be discussing about two types of processor, the single general purpose processor and the multiprocessor systems. Okay. So what is meant by a single general purpose processor? If you take a typical computer, like a normal desktop, personal computer, or a laptop, which we are using in day-to-day life, they generally have a single processor. Okay, such computers are called as single general purpose processing systems. Okay. Okay, nowadays the computers are coming with multi-core systems, even laptops or personal computers also. But if you just go back by 8 to 10 years, no, most of the computers used to have only one processor. Okay, so such computers are called as single general purpose computer system. Okay, but these computers will also have special controllers for each of its hardware devices. For example, memory will have a controller called memory controller, and hard disk will have a controller which is called as hard disk controller, and network interface card will have a controller called network interface controller. Okay, so these are special purpose processors which are dedicated for a particular job. For example, memory controller used to control only the memory device with the help of operating system. Nothing else it can do. Network interface controller, it is used to control only the network related tasks. Okay, if any data is flowing out of the computer or any data is coming inside the computer, only it will deal with that. Okay, so these controllers are otherwise called as special purpose processors. Okay, whereas whereas the CPU that is running in the system, that the CPU that is placed in the system, that is called as general purpose processor. Okay, so what does it mean by general purpose? General purpose in the sense, these processors can be used for different types of tasks. For example, the processor may be used for running a game application. It can be used to run an accounts related application. It can be used to run an Java application. It can be used to run a spreadsheet. Okay, like varied type of applications can be executed through these processors. So it is called as general purpose processor. Whereas the controller or the processor that is located in the hardware devices like printer, memory, or or other hardwares, these are used to control only that particular device. So these are called as special purpose processors. Okay, so every computer will have these special purpose processors, because every computer will have some or other hardware devices. Okay, as they have these special purpose processors, because of that we cannot call a computer as a multiprocessor system. As long as a computer has only one general purpose processor, it will be just called as a single general purpose processing system. Okay, so this is how we define a single general purpose processing system. Now let us try to understand what is a multiprocessor system. A multiprocessor system is one where the computer will have more than one processor. Okay, if a computer or a PC or a laptop has more than one processor, then such a computer is called as a multiprocessor system. This multiprocessor system is also called as parallel systems or tightly coupled systems. These are other names for multiprocessor system. So what is the advantage of having a multiprocessor system over a single general purpose processor? There are three main advantages of a multiprocessor system. The first advantage is by having a multiprocessor system, the throughput of the computer will increase. So what does it mean by throughput? Throughput means work done by the processor in a unit time. The amount of work done by the processor in a unit time. Okay. Say for example, if the computer has only one processor, and with this one processor, if the computer is able to do some a amount of work, some a amount of work in a unit time, then if that computer has n processor, then it doesn't mean that it will be able to do n into a amount of work. No, the amount of work that will be done will be somewhat lesser than n into a. Okay, but still the amount of work done will be considerably, it will be an improved amount of work will be done. Okay, so this concept is called as increased throughput. Okay, so you may ask, when there is one processor, the amount done is a amount. So when there is n processor, why the amount of work done is not equal to na? The reason is, as you increase the number of processor, the system overhead will increase. Okay, because operating system has to deal with two processor, or more than one processor, and all the resources should be shared among these processors, so the overhead will also increase. So you have to compensate on that. So by compensating the overhead involved, finally the amount of work which the system is capable of doing will increase a considerable amount. Okay, but it will not match to that proposition of that many n processes. Okay, so this concept is called as increased throughput. The second is economy of scale. What does it mean by economy of scale? Economy of scale in the sense, say currently I'm having only one computer. Okay, but I'm not happy with this computer, because say I have only one PC, but I'm getting a lot of work. So this one PC is not sufficient to complete all my work. Okay, so what I'm deciding is, I'm deciding to add one more PC. So now I'm getting one more PC. Okay, so then if I want to get one more PC, then I have to invest this much amount of money. Say if this PC cost 30,000, then I have to spend another 30,000. Okay, so it will become 60,000. Okay, so which is because I have to invest on two computers. But instead there is another option is available. Instead of adding one more PC, what I can do is, in this computer itself, first I have one computer. To this computer itself, I can add one more processor. Initially, this may be a single processor system. Now to this, I can add one more processing element, which is called as processor. So if I add one more processor to this, probably the performance of the computer will increase quite a large amount, and also the extra cost which I have to spend will be around 5 to 6 lakhs. Sorry, 5 to 6,000. It will not be more than that. Okay, but if you go for a new PC, then the cost you have to spend will be 60,000. Okay, so this is called as economy of scale. Okay, as you increase the number of processor, the amount you are going to spend is comparatively less if you compare with purchasing a new computer. Okay, because a new computer it will come with all the resources like memory, hard disk, other extra resources. But here with one PC, you are adding one more processor and you are sharing the existing resources. So this is the second advantage, which is called as economy of scale. The third advantage is increased reliability. So what does it mean by increased reliability? Increased reliability in the sense, in a multiprocessor system, so we are discussing about multiprocessor system. So in a multiprocessor system, a typical computer will have more than one processor. Okay, So even if one of the processor fails, say assume that the computer has three processors. So if one of the processor fails also, the job will not be stopped. The operating system will just divide the job to the remaining two processors, and the job will still continue to happen. Maybe the work may be completed uh, uh, in a for completing the work it may take more time. Okay, that is, the performance may degrade by certain extent. The performance may degrade by 10 percentage or 15 percentage depending on the amount of hardware failure that occurred. Okay, so in spite of the hardware failure, the system will try to will continue to perform its functions. So this concept is called as increased reliability. So increased reliability happens in two ways. One is called as graceful degradation. The other one is called as fault tolerance. So I will give one example for graceful degradation. So whatever the example I quoted previously, that comes under graceful degradation. If if there are three processors and if the operating system is sharing the work to all the three processors, and if suddenly one of the processor fails, then the operating system will share the task to the rest of the two processors. Now what happens? The task will be completed, but it may take more time. That is, the performance may degrade by certain degree. So this concept is called as graceful degradation. Whereas there is another type which is called as fault tolerance. A fault tolerant system is one where, in spite of hardware failure, the system will continue to perform its function without any compromise with the performance. Okay, even if there is some hardware failure, the system will continue to work, and it will provide the same performance, just what the performance which we are getting even before the failure of the hardware. Okay, so this concept is called as fault tolerance. Okay, how it is achieved in the sense of course, fault tolerance is a costly operation. You have to keep many hardware devices as a backup device. Okay, so maybe so you will have some backup devices. So if one of the device fail, then the other will compensate it. Okay, so one example for fault tolerance is, you can say assume that I have a pair of processors. I have, say assume I have three pairs of processors. So this is first pair, this is first pair, this is second pair, and this is third pair. So each one is a each of this contains a pair. Okay, it means it has two processors, and this has two processors, and this has two processors. Now what happens in the sense, uh, initially normally the computer or the operating system will be using only this particular pair, and this two will be kept as backup. We are not using it. It is just a backup, and this will be used only if there is any issue occurs. Otherwise, the operating system will not touch this. Okay, this is just a backup. Now, when any computation comes, the computation will be given to this pair. Okay, here we have two processors. So both the processor will perform the task, and it will produce the output, and the output will be compared. So this particular entity, it has two processors. So the job will be given to both the processor, and both of them will produce the output, and the output will be compared. If the output matches, if both the output matches, then it means that it is working properly, and this will continue its job like that. Say at one point of time, the output produced by, say it has two processors, right? So the output produced by one of the processor is not matching with another processor. Then it means that one of the processor has failed. It means one of the processor has failed. Now what the operating system will do is, operating system will not use this pair of processors. Rather, it will start using this another pair. Okay. So now there is a failure, but still, in spite of the failure, your system will function with the same amount of performance. Okay, so basically fault tolerance system, what it does is it tries to identify the fault and also it will try to rectify the fault. Okay, but it needs a lot of resources and it is a costly operation. Okay, and there are two types of multiprocessing systems available. The first one is called as asymmetric multiprocessing and the second one is called as symmetric multiprocessing. In asymmetric multiprocessing, if you have, say if you have 3 or 4 processor, then one of the processor will act like a master and other processors will act like a slave or like an employee or like a worker. Okay, so one of the processor will act like a boss or like a master and all the remaining processors will act like a worker. So this type of setup is called as asymmetric multiprocessing. So the one processor which is acting like a boss, that will decide like what the other processors should do, and all other processors will just perform that task which is assigned by the particular boss processor. Okay, whereas in a symmetric multiprocessing environment, all processors will be treated as equal peers and operating system will just assign the task for each of these processes. Okay, so this is a brief introduction about single general purpose processor and multi-processing system. So what we have discussed is any computer which has only one processor is called as single general purpose processing system. If a computer is having more than one processor, then it is called as a multi-processor system or parallel system or tightly coupled system. The advantage of using a multiprocessor system is it will increase the throughput, it, it produces economy of scale, and it increases the reliability. Okay, so reliability can be increased in two styles. One is a graceful degradation, the other one is a fault tolerance. Graceful degradation in the sense, depending on the amount of hardware failure, the performance of the computer will gradually decrease. Whereas in a fault tolerant system, in spite of hardware failure, the system will continue to provide its best performance without any compromise. And multiprocessing systems are broadly classified into two types, asymmetric and symmetric. In an asymmetric multiprocessing system, one of the processor will act like a boss and the other processors will be acting like a worker. Whereas in a symmetric multiprocessor system, all processors will be treated as equal peers and operating system will assign jobs for all the processors. Okay. So that's it. We'll stop here and we'll continue the topic in the next lecture. Thank you.